As I mentioned in the previous example, contextual problems have certain restrictions which may limit the possible answers. So whether it's going to be a positive number or negative numbers, or if there's going to be decimals or not, and each variable can have different restrictions to it. And so we're going to look at two big words here. Well, I guess they're not really big, but they are pretty important, and that is domain and range. Now, the domain is going to be, it's all the restrictions that are placed on our x, or independent variable. Okay, so it depends on what we have for an independent variable. And we could have a number of different ways of writing this. So types of numbers which are shown will be as such, and this will be for domain. I should have maybe put that in there. I'll have to change that in my master copy of the notes. It's going to be domain of numbers. Okay, so different things that we could say. Let's say all numbers, our x's have to be greater than 0. Well, we could say that x has to be greater than 0. Or we could say x is greater than or equal to 0 if 0 is a possibility. Okay, so that would be something. Maybe we only want to deal with a small section. Okay, maybe we only want to deal with small section, and we can look at that too. So that would be, let's say, if numbers are greater than 0. Now, if we're saying that we want numbers which are only no decimals, okay, no decimals, well, then we could say that x has to be a part of the integer category. Okay, so this little symbol here means a part of, and I represents integers. Okay, integers. Let's see if we can get that a little bit nicer. Okay, so i's would be if it's all integers. Okay, now let's say that it would be, instead of integers, we don't want any decimals, or sorry, we don't want any negatives. We just want, so this would be like positive, negatives, but only the nice numbers like -1, -2, -3, and then 1, 2, 3, so on and so forth. Let's say we don't want any negatives, we only want positive numbers. Well, we could say that it is a part of all, x is a part of all whole numbers. Okay, so this would be whole numbers. Okay, so this would be like 0, 1, 2, 3, and so on and so forth. I have a list of the different types of numbers, or the numbering systems, it's on the Google Drive, and you can take a look at that. It represents what all the different numbers are. So that'd be like integers, so if negatives, positives, but no decimals. Whole numbers would be if we're starting at 0. If we want to do, so that would be normal. If we don't have 0, these would be called, now I'm forgetting the type of number here, but we could have ones that don't have 0 as well, and but we don't normally have that. Let's say that all numbers are possible. Okay, so there are no restrictions. Everything is possible. Then we say that x is a part of all real numbers. And so the r represents real numbers. And this is all values. Okay, so everything is a possibility. So that would be, the x's could be all numbers. So there is not a value of x that does not work. Now, if this isn't, you're not totally sure on this, we're going to go through a number of examples, and we're always going to go through our restrictions on it. But these are just a couple of ways that we can do a set of numbers that we go off of. Now, if we're going to say, let's imagine that we only deal with a small little bit of numbers. Let's say that we want to restrict the number of students to 15, but we could have anywhere between, let's say, 1 and 15 students. Let's just say that. Well, then we're going to write it out something like this. 1 is less than or equal to x, which is less than or equal to 15. What this is saying is that x has to be greater than or equal to 1, and x also has to be less than or equal to 15. Okay, and another way that we could kind of write this out, and I'm just going to grab a different color here, is we're going to have our lower limit is less than or equal to our x value, which is less than or equal to our upper limit. Okay, and I'm just going to put these into boxes because this is going to be, it's kind of like the number that we're going to change into. 1 is our lower limit. Okay, so that's the smallest value that we could possibly have, and 15 is the biggest possible value we could have, and so that would be our upper limit. This is how we would represent it. 1 is less than or equal to x, less than or equal to 15. This is a restriction that's put into place to say that our x value cannot be less than 1 and cannot be bigger than 15. Okay, everything in between works, but this is kind of our upper and lower limits there. We're going to really look at this into our next unit when we talk about quadratics, because then there's a lot more limits. In linear inequalities, we're often going to use something like this. Okay, it's got to be greater than 0, or it could be all numbers or whole numbers or integers or something along those lines. So that's a way of writing it out, and just kind of giving what our domain is. Now, range is the identical thing, except it's all of our y or dependent values. Okay, so it's all the restrictions that are put onto our y values. So we could write out, and again, this is going to be very similar. We could say that y is greater than or equal to 0, or y is greater than 0, something like that. We could use any number for that. And again, when we get into quadratics, we're going to start looking at a bunch of different ways of doing it, or a bunch of different systems in that case. But for right now, we're just going to take a look at these, just the zeros. We could also say that y is a part of all integers, and that should be 2 actually. The I symbol is a 2. We could say that y is a part of all whole numbers. Y is a part of all real numbers. Okay, something like that. Exactly like we do with domain. This just represents what our y is. Now, our x and our y are not necessarily always the same. Okay, sometimes so if we use the example we had prior, where x is the number of students and y is the cost of the party, x cannot have any decimals, but y could. Okay, so that would just dictate kind of what our domain and our range would be. In the same way that we did before with this here, we could also have a lower limit for y is less than or equal to y, which is less than or equal to our upper limit. Okay, so we could have the same thing, and now let's say with y, we have something like -6 is less than or equal to y, which is less than or equal to 12. Okay, so that just means that our y value has to be between -6 and 12. Those are the only values that work. There's our lower limit, there's our upper limit. And so it's important to understand how to write this out. Now again, this is going to come into play when we start talking about quadratics, and I may actually give you this video again in quadratics, the exact same one. We'll kind of see how that goes. But this is what domain and range are. Okay, domain and range are a part of every single graph. We can use it on any single graph. And if you're having questions on domain and range, please reach out to me, and we'll go over how to come up with a domain and range or how it looks. Now, all the examples that we're going to do on the next couple pages, I'm going to go through what the domain and range are. Okay, some are going to be really simple, some are going to be a little more difficult. And again, we're going to use this in quadratics next unit as well.